Hello everyone, welcome to my channel. Starting from today, I will do the LeetCode problems with you together. The programming language we're going to choose will be Python 3. For each video, we're going to solve one of the problem. I will also notice the approach methods through the title. For the simple ones, we will combine all of the approaches in one single video. For others, I will record them in separate videos. So please do check the message below and see if there will be any other ways to solve the problem. Okay, thanks for choosing us, and let's just get started. The very first problem we're going to solve is the most classical topic, or we say the classical problem we can see from the LeetCode. It is number 1, which is called the two-sum. This problem belongs to the easy category, and the data structure of this problem is based on the array. For the approaches of the solutions, we're going to have 3 different ways. The first one is brute force, the second one is hash table, and the third one is 2 pointers. Before we go into any details of the solutions, let's just review the description of this problem and just trying to understand what it is asking for. So for this problem, we have 2 inputs. The first one is called nums, which is an array of the integers. The second one is target, which is an integer itself. So we need to return the indices of these 2 numbers. These 2 numbers should be added up to the target. So the value of these 2 numbers, the sum of it would be equals to this target number. We should assume that each input would have exactly one solution, so we must have like one solution, and we cannot use the same element twice. So for each element, we can use only once for our like adding up solution, and we can return the answer in any order. So like if you have 2 indices, that is 0 or 1, we can also return as 1 0. So that is the problem's description, and let's go through the examples and get a better understanding. So for example 1, we have like input as nums is equals to 2, 7, 11, 15. There's 4 elements, and the target is equal to 9. So we can just manually say like which 2 numbers added is equals to 9. That is very simple, right? That is number 9 and the number 7. The indices of these 2 numbers is 0 and 1. So the output is just 0 and 1. Example 2, we have the input nums as 3 elements, which is 3 to 4, and the target is 6. So it is also easy to say like 2 added 4 equals to 6. So the indices of these 2 numbers is 1 and 2, then the output will be just 1 and 2. Example 3, we have 2 numbers, which is 3 and 3. The target is equals to 6, and the output is equals to 0 and 1, because 3 plus 3 equals just exactly to 6, which is the target number. So that is very easy for us to just manually say what is the solution and what is the output. But if you need to like convert it into like a programming languages and implement it through the Python, then that will be another story, right? So let's just do the very first solution. So the solution 1 is which is called the brute force. So for the brute force, we just need to like go through the element of this input array, and we will just compare any 2 pairs of these numbers. So let's say from the examples first. So before we just doing any coding things, let's just trying to understand the logic behind the algorithms and just trying to like describe in the language word. So the first one is we will have like 2 pointers. The first one pointer is will just indicate we just point to a particular position of this array, and the second one will point to the other position of this array. So when the I pointed to 2 and the j pointed to 7, we will just compare to say if the numbers of I and plus the numbers of j is equals to the target or not. So currently, we are going to say the relationship between the numbers of I plus numbers of j. So what is the relationship between this one and of the target? So if that is didn't it's not equal to target, we need to move I and j, these 2 pointers, and find the next match. So maybe for the next one, j will point to 11 and I still point to 2. Then 2 plus 11 is 13, which is also not equals to 9, right? And we will just keep going. And after j reach to the bound, then we will come back and let the I to the 7, and then we will just go through the array of the rest of the node again for the j pointer, and then add them up and to say if the sum is equals to the target or not. So for the brute force, we actually will have like 2 loops. So the first one is we're going to go through all of the elements from the I pointer, and the second one is we will go to all of the elements within the array from the j pointer. So let's write it together. First, we need to know the boundary of the numbers. So we need to know where is the right boundary, when will you just get out of this array. So n is equal to length of the nums, and then we will write the for loop. So for the very first for loop is for the I, with the very first pointers we're going to use, and the second one is the j. J is the other one to indicate for the other number, and we will need to compare the relationship between numbers of I plus numbers of j and compared to the target. So if it equals to the target, then we are going to return the indices of I and j. If not, then we will just keep going, keep doing the iteration until it's out of the range. So since we already know that there is exactly one solution, so there is no case to say that there is no solution. There is actually, we can make sure there's one solution. So from here, we do not need to write any other exclusive options. But for most of the in general ways, normally if there is go through all the elements and go through all the combinations, then if there's no 2 element sums up to the target, we can just return it as -1 to indicate that we cannot find any 2 sum combinations which added up to the target. So this is the same logic, but we still need to add one more thing before we submit. The one thing is we cannot use the same element twice. So when we go into the iteration of the I and j, it is possible I and j actually indicate to the same number, right? If the I equals to the j, then we will just have the 2 pointers pointed to exactly the same position. So since the problem doesn't allow this situation, we will need to add this to our content, or the condition. So the condition will have one more, which is I cannot equals to j. So after we added this part, then this is a whole solution for the brute force approach. Let's submit first. It's kind of slow because for this kind of approach, it has a very high time complexity, and it is not the most recommended solution. But we still good to know of how to approach through this way. So for the time complexity, since we're going to go through the whole array for twice, there's a for 2 for loops. So the time complexity would be, let's just say it here, the time complexity would be 2 to 2. N to 2, so that is n squared. And for the space complexity, since we are not going to install any of the other places, extra spaces for of these 2 arrays, then we will just say that space complexity would be of 1. So this is the very first approach for the 2 sum, which is called the brute force. The next one is we're going to solve these problems by one pass hash table. So hash table is a very good or efficient way for us to use for this problem. So hash table is currently we have 2 2 elements in this for each pairs. So we have a key and also have a value. We can just have the key as our the number's value, right? And the value we can say it as the index. So once we have these 2 pairs of informations, then we can check back to the hash table to see if we can find the solutions, or we can find the 2 elements adding up to the target. If we can find that way, then this is how we solve this problem. Let's write this one together. So first, we can use the dictionary to approach for the hash table. Oops, give me 1 second. Okay, we create an empty dictionary, and the next step is we are going to write another for loop, because no matter what, we are going to go through all of the elements in this array from the start to the end. So we will have a pointer as I, and we're going to do the for loop from the range 0 to the length of the nums. And after we do the for loop, within this for loop iteration, we will just compare if the target minus the numbers of I is in the dictionary or not. If that is not in the dictionary, then that means we are seeing the new number, and that may be possible we can use in the future. So we can add them to the nums. Add them to the dictionary, or we say the hash table. So the key would be the numbers of I, which is the nums value, and the I would be the index. So this is how we add it to the dictionary. The else situation is that we can actually find a number which is in the dictionary. So in this way, we can say that if we have a target and we have one of the numbers, and we find another number which is equals to the target minus numbers of I in the dictionary. So we already know the index of one number, and the other index of that number is actually restored in the dictionary. So we can just return the result. The return part is we will have the dictionary to find out the find out the index of that number, and the second one is the index of the current number. So let's just submit. This is the second approach, which is called one pass hash table. One pass is we go through of this array just like for once, and hash table is we need to use a dictionary as our hash table to restore the numbers information we have already looked into. So from here, the time complexity would be 1 second. The time complexity would be O of n, which is we go through the whole array for once, and the space complexity would be also O of n, because we need a dictionary, and the actual space required depending on the number of items stored in the hash table, it can up to the n numbers. So we can up to store all of the elements in the dictionary. So the space complexity would be O of n. Okay, this is the second solution, and then the last part is we can go to the third solution, which is the 2 pointers. So for the 2 pointers, kind of complexity and not very efficient for this particular situation, but still we're good to know a different approach. For the very first time when we're trying to say we want to add it to some, always select 2 numbers together and to say the sum if that is equal to the target, we need to have this array as a ascending order, because for the 2 pointers normally we start from the most left side and also the most right side. And once we have this sorted array, we will just say that I have 1 pointer at the very beginning, like we say the start, and we have the other one at the very end of this array. And when we add the numbers of the start and the numbers of the end, then we will compare with the sum up value with the target, right? So when we compare, then if that is equal to a target, that was very easy. We can just return the start and the index. But if that is larger than the target, which means actually we need to have a smaller number. But since start is already find the most smallest number in this array, so we need to move the end pointers to the left side, because the left side always is slower than the right side if we have a sorted array. So in this case, end would be the we'll end to the position which is the left side of the current position. So we will say n is minus equals to 1, which is and is equals to and minus 1, right? And if that is the opposite position, we say if this two sum is smaller than the target, since n is already have the largest one, so we need to change the start pointer. Then the start point would be start is equals to plus equals to 1, right? So start will be the next pointer on the right side of the current pointer. So we can use this ways to know like how can we just choose the correct like two numbers. If the start and end point actually meet at the same position or they cross off each other, then we say we go through of the array, but we cannot find the correct answer. So the problem with this solution is we cannot say like the input array is a sorted array, so we have to do the sorted function first. We need to sort it of the input array, or we say the input nums, and make sure that it's in the ascending order. If that is in the ascending order, then we can use the 2 pointers to solve this problem. And the other problem we might meet is when we just do the sorting of this like array, we will also lose the initial, or we say the original indices of each element. So we have to install the initial index of this each element somewhere. Then we will using the enumerate functions of the Python. So let's write it together. The very first one is, as we just said, we need the index and the numbers values before we do the sorting. So we have the index and having the numbers for the index of the num in numerate of the nums. So we have to like just generate of the index and the nums from the nums itself, and restore the original nums and its original reference like index. After we have all of this information, we can just sort the nums itself. So when we call the sorted function, we're going to say like sorted parentheses and nums. After we sorted this whole like array, we're going to like using 2 pointers, one from the left side, which is the start part, and the one from the right side, which is the end of this array. And the start point is from the 0 index, and the right point is from the length of nums minus 1. And we will next is going to a while loop to go through all of the elements within this array. So the end point, I always say the start point, is when the left pointer is larger or equals to the right point, because you cannot using the same element twice, and we cannot let these 2 pointers across each other. So within this whole process, we can just compare the sum value with the target value. So if the nums of the left, and we'll remember to add 0 here, because within this nums we have 2 values. The first one is the nums itself, and the second one is the index. So when we compare, or we say we'll do the sum up, we're actually using the nums value itself, and then we will have it here. We added them up and compare with the target. If that is larger than the target, then we will say right will be minus 1, right? Remember we just said if that is larger than target, we need a small number from the right side. And it's else if this one is in the opposite like scenario. We say if the nums plus these 2 values is smaller than the target, then we will say left would be left plus 1. So we just write it as left plus equals to 1. And the last part is we have the else scenario, which is the sum up is just exactly equals to the target. Then we find the solution, right? Then we just need to return the solution. We can just sort it or not, but we can use the sort here to just return it in the ascending order. So from here we have the nums. Oops. Oh yeah, I'm correct. So from the nums we have the left the value, and we need to indicate the index. So for the index we need to add the 1 here. So Rebecca again, so 0 here means the nums itself, and the index from here means the index of the original position of these numbers. Okay, once we have this one, we also need to have the right one. So let's run the right one here, and that is what we need to return. And at the end, we can just return minus 1 1 minus 1 in case there is no like solution. But again, from this problem we exactly have one solution, so this one is kind of redundant, but it's also still good to have. Let's submit this problem. Okay, let's see what happened. Okay, it's larger list of the int. I think somewhere I maybe did something wrong. Let's see. Nums is equals to the nums index for index nums in enumerate nums. Nums sorted the nums. We have the sorted array, and we have the left-right pointers. And from the left-right pointers, we are going to. Oh, okay. The problem is from here. We just see nums. Actually, we need to use the num because we for each element in the nums, that is, we're using the index and num. But for there, we just like typing the nums as a tuple. Okay, let's submit it again. Okay, it is successfully passed of the test cases. For this one, actually, we need to consider the sorting function time complexity before we actually using any of other like ways to calculate the time complexity. So from the whole part, I mean, after we have the sorted array, the time complexity will be O of n, right? We will go through all of the elements just one pass within this array. But when we call the sorted function in Python, the built-in function actually have a complexity with n log n. So the whole solution for this approach is have the log complexity as O of n log n. This is the reason why we're not using this problem to solve this using this solution to solve this problem, because it have a higher like time complexity. And for the space complexity, since we're going to like store the the sorted array in a separate place, so from here we're using the space complexity also as O of n. If you still remember our solution 2, the time complexity and space complexity are all of O of n, so that is kind of optimized approach compared to this one. And even for the the brute force solution, even though the time complexity is a little bit higher, it's n squared like O of n squared like level, but for the space complexity it's just like O of 1. So we have different approaches, and we just want to say that the third one kind of is the most fancy one, but this is not the most efficient one. For the learning purpose or the exercise purpose, you do not have to like exactly need to find the most optimized ways to solve the problem, but it's good for you to like open your eyes and see like different approaches and just trying to practice all of them, like just get familiar with all of the approaches and all of the solution ways. Okay, thank you. Then that should be all for this video. Hopefully help you to understanding this problem, and hopefully to help you to solve this problem. Thank you so much. And if this is the very first time you just watch my videos, please do subscribe my channel and give me a thumb up. And thank you again, and see you in my next